2017 12A 24.
2017 12A 24. Let me open it. Okay, quadrilateral ABCD is inscribed in circle O and has side length AB3, this one, the 8. So 2, 3, 2, 6, 8. So 3, 2, 6, 8. Something like this. And A, B. Let X and Y be points on BD. Okay.
Mm-hmm.
DX over BD is 1/4. So let's consider this something like this. And BY over BD 11 over 36 is around 1/3. So it will be something like this. Let E be the intersection of line AX and the line through Y. Okay. So this one, let me E be the intersection of line AX and the line through Y parallel to AD. Okay. So let's here. It is FB intersection of the CX. Okay. CX and the line through E parallel to AC. So it will be something like this. AC, AC. We call it F. And it says let G be the point on circle O other than C that lies on the line CX. It is G. What is XF? Okay, so look, this one is parallel to this one, right? This line is also parallel to this one. So here we want to find XF times XG. So when you see product in geometry, what are important rules that you can use?
Power of a point, because there's a
Power of a point, what else?
Power of a point, maybe Siva's theorem.
The next case is a special case of power of point is a special case of that. The proof of power of point is by what?
I don't remember.
Similar triangle.
Oh, okay.
If you want to prove power of a point, similar triangles, and when you cross multiply, you have product, right? At first, you have division, right?
Yeah.
Okay, so similar triangles is the background idea of also power of a point. So when you have product, 90% of the cases, triangles can be useful. And because we have parallel lines here, so we can write some similar triangles. Also, we have cyclic quadrilateral. So let's list all similar triangles and let me call this one. We didn't have P, I think, the points. Okay, so let's call this. Can you tell me what are the similar triangles here?
Triangle AXC is similar to triangle FXE.
Exact. CA corresponds to what?
FE.
FE. CX corresponds to what?
XE.
Because this angle is equal to this angle, so you can say X. And AX corresponds to what?
FX.
Yeah. Another similar triangle. And look, XF we have here, it's good. But we don't have X, right? So also we
Nope.
should work on X. And so what else? What is the next similar triangle that we can write?
AXD similar
AXD
to triangle.
is similar to
EX,
XYE, right?
is that the right order? EXY.
Yes, XYE or
All right.
EXY. Then let's try the game. AD corresponds to what?
E corresponds to EY.
Yes, XD corresponds to what?
EXY.
And XA corresponds to what?
EX.
XA. Let me check it again. Here. If
You
this
didn't
one.
write the angles in the right order, so
Check here. CX. CX is opposite to this one. So opposite to this one, CX is
wait,
X.
the angle
So
is just
here XF.
what?
Agree?
Why?
Because look, CX is opposite to what? This angle, right? Because these two lines are parallel, this angle is equal to this angle. CX is opposite to this one is XF, not XC. Agreed?
X AXC and oh, okay. XD over XY equals XA over XE. Yeah, okay.
So XA corresponds to what?
XE.
XA corresponds to, yes, XE. Okay, so here we found something for XF, but still we have problem for working with the other length, right?
Mm-hmm.
So what should we do here to find, for example, something for XG here? We have some relationship for XG. Can you tell me XG times what is what times what?
XG times XC is equal to XD times XB.
Exactly. So we have something for XG, for XF also. We can use this part is equal to this, or this part is equal to this, right?
Yeah.
Here we have CX, here we have XC. Oh, so much good, because XF over XC is equal to EX over AX, right?
Yeah.
So if we multiply, do you agree we can cancel XC?
Yeah.
So XF times XG is equal to what? XD, XB, EX, AX, right?
X. Yeah.
Okay, so
But,
now you said what?
where did the X? Wait, what did you substitute? What was the
Look, do you
substitution?
agree this part?
Yeah.
Do you agree this equation?
Yeah.
Do you agree we can consider reciprocal on both sides?
Yeah.
So if we use reciprocal, do you agree we will reach this?
So you said XC equals
No, I didn't
AE
say
times.
XC equals. I can't say only reciprocal of both sides. We will reach.
Okay. Yeah.
Then I multiply. Why I did this? Because I don't like XC. I said, okay, we have XC here, we have XC here. But if I consider reciprocal and then multiply, we can cancel XC. Then it will be XG, except the thing that we want, right?
Yeah.
Then you should multiply this XC, XB, EX, AX, right?
Yeah.
Okay, now we should calculate these parts. All things related to X, right? X, let's write XE. AX xd, ex, and what else? xd. And one good thing. Do you agree xd, xd, and this one? And xp, they are related to each other, right? We can change these two variables to one variable, right? Because we should remove variables to reach the number, right?
Yeah.
And then we have xe and ax. Then, for example, we should see, okay, if we find ratio, and for example, similar triangles, one thing, do you agree here, for example, we have xd over xy. So we can find this is equal to what number, right?
XD and XY.
Yes, because look, it says the relationship here, the relationship here. You can find this one, right?
Yeah.
So try to find this and try to see, can you simplify this to reach a number? Try. If you couldn't, let me know to give you this, okay?
Okay. Okay, I got 17.
17 for what? For the question mark?
For the answer, yeah.
Okay, so because we know dx is equal to bd over 4, right?
Yeah.
And by
I called BD P.
is equal to bd over 4. So xy, bd times 11 over 36, right?
Yeah, I just called BD equal to P.
Equal
for
to?
simplicity. P over 4. I just said it's equal to P over 4.
Okay, P over 4. So P over 4. So 11P over 36. Here we can also say 9P over 36, right?
Yeah.
And XY is what? Is 20, 16P over 36, right?
Yep.
Okay. So because here it says XD is 9 over 36 over 16 over 36. 9 over 16, right?
Yeah, so EX over X, 16 over 9.
Okay, so here we found this relationship. In this part, CA, so we know AD, EY, XE, for example. XE, AX, right?
Mm-hmm.
So XA is better than XE, I agree, because E, you created this one, but AX is better. So XF times XG. So XE over AX is what? 16 over 9, right?
Yep.
XD, XB.
Yep.
So it is 16 over 9. XD is what? 9P
XD
over
is P
36.
over 4. Yeah, okay. P
Yes,
over
or
4
P
times
over
3
4.
P over
Yes,
4.
yes. P
Times
over
3P
4,
over 4.
XP is
3P over 4.
yes, 3P over 4.
Yep.
So
now you
it
got
will
P
be
squared.
4 for
P
this,
squared over 3.
P squared over 3. So the only thing you should find is length of BD, right?
Mm-hmm. Mm-hmm.
Okay, so here I think we can erase all these things, right?
Yeah.
So here, this one, BD is P. And this one is 3, this one is 2, this one is 6, 8, right?
Yeah.
3, 2, 6, 8. Okay, so and this one 11, 36. So you should find P is what, and then this. Want hint or want to try this on your own?
I already solved this.
Okay, so your answer, how you calculated this?
I use law of cosines.
For this one and this one, right?
Yeah.
Okay. So here we said this cosine is 2 squared plus 6 squared minus p squared over 2 times 6, right? Is equal to 3 squared plus 8 squared minus p squared over 2 times 3 times 8, right?
Yeah.
Then you can cancel 2, 2, 2, 6, 3, 4. Here is 2. 3, 3, right? So
Yeah.
4 plus 36 is what? Is 40. 9 plus 64 is what?
73.
Yes. So 2 times 40 is 80 minus 2p squared. Agreed.
Yeah.
Is equal to 73 minus p squared. So 80 minus 73 is 7. 2p squared minus p
Oh,
squared.
no, that's not right. What?
You said what?
That's not no. Why is p squared? How'd you get p squared equals 7?
So let's check it
Okay,
again.
wait.
Yeah,
Can we just write it normally? So 73 minus 48 cosine theta is equal to 40 plus 24 cosine theta. Cosine theta equals 11 over 24. So 73 minus 48 times 11 over
one
24
thing. Sorry.
is
Here
51.
negative of that because the cosine is negative.
Okay, yeah.
So
Yeah.
if we cross multiply, it will be 80 minus 2p squared is equal to negative 773 plus p squared, right?
Okay.
So 153 is equal to 3p squared. Agreed?
Yeah.
So p squared is 51. So p squared over 3 is 7, right?
Yeah.
Okay, so the answer is 17 choice, right?
Yeah.
Okay, good job.